Right, so last section we're going to look at this week is 9.4, if you're looking in your book, but we're going to do it out of this packet, which is section 6.2. So next two sections are going to be out of packets, all right? We're going to look at what's called the conic sections. Okay. And there's 4 different conic sections. We're going to look at the parabola today. Circle we've kind of done a few things with throughout the year. Like when we did equations earlier in the week, we drew circles. So we've done a little with circles. But we'll look a lot at ellipses and hyperbolas next academic week. So parabolas are kind of like their own thing. So it's kind of good that we're only getting that one section done because we can get parabolas done. And then ellipses and hyperbolas are kind of the same formulas. So we'll do both of those together next time. So the conic sections just come from the different ways you can slice a cone. Okay? And then look at the cross section. So if you take a cone and then just cut it straight across, and then look at the end, you'd have a circle shape. Kind of like cutting like a roll of like paper towels. Like if you took the roll and then cut it in half when you were done and then looked at it, it would be in the shape of a circle. Now, if you cut a cone on an angle, but you go through the sides of the cone, not out the bottom, okay, through the sidewall, the shape that you'll end up with is an ellipse when you cut it on an angle. Now, if you cut it on enough of an angle that you come out the bottom of the cone, you're going to get a parabola. Okay, that's where you slice it. It's like you slice the side of the cone off, and then you go right through the bottom. Hyperbola is a little different. That's where you put 2 cones with the vertices connected and slice it straight down. And you end up with basically a shape that looks like this. Right? It's almost like, kind of like having 2 parabolas, but they're in separate pieces because you have 2 cones. I'll talk about a few things that you can use these shapes for. I'll do something with, I'll do cars. All right, so every conic section has a definition that always starts out as it's a collection of points, and then there's some condition. Right? The simplest conic section I could describe to you would be a circle. Okay? That would be a collection of points that are all equidistant from the same point. Okay? So basically, think of like putting like a thumbtack or something in like a board. Take a piece of string, keep the string pulled tight, and draw on every point that you can that's exactly that distance from the point. And that would give you a circle. Parabola is a little different. It's a collection of points, first of all, in the plane. That means it's a flat shape. It's not a 3D shape. So it's a collection of points in the plane. And every point is the same distance from 2 things. With a circle, every point is the same distance from one thing, the center of the circle. Okay, so in a parabola, every point is the same distance from a special point we're going to call F, and a special line we're going to call D. And I'm going to show you a picture of that. Okay. So what that definition is basically saying is that if you put a point on a parabola, okay, pick anywhere you want, pick a spot on a parabola, and measure that distance to a special point called F, which has a name I'll tell you in a second. And then measure the distance from that same point to a special line called D, it always comes out the same. So here's a parabola. Point B is just a point on the parabola. I can move that point anywhere I want. Point A is that special point that I called F. Okay, I had called it F in this program, they call it A. This line up at the top, that's the line D. Yeah.
Is A like the middle of the parabola?
It has a name that I called it F because the name of it actually begins with an F. It's called the focus. But we're going to write that down in a second. So if I measure the distance from B to A and from B to C, it will always come out exactly the same. I can move B, and as I move it, these two distances will update. Okay, so watch. So I moved B, but look at the distance from B to A, it's 15.56. The distance from B straight to C is still 15.56. These two distances will always come out the same. And if they don't look the same, it's really just an optical illusion. They are the same. They're the same. Okay, and I could drag it. If I put it right there, they're exactly the same. I think that's the easiest to see that they're the same, like right there. And if you go over here, they are exactly the same. You think that one is longer?
Yep.
You do?
Yep.
Sure?
Yeah, sure.
We're going to do this?
No, I know it's not. I'm just saying it looks longer.
It only looks longer when it's like that, though.
So let's go like this. Let's go here. So there's the picture. Still looks longer.
How'd you get there?
Magic. All right, let's go like this. Let's take that, and we're going to put that right there. Still looks longer?
Yeah.
Yes.
I'm going to put that right about there. You sure?
I'm sure that it looks longer.
Okay. I'm going to put that like that. I'm going to put that over there like that. And
I don't know, one of those is a little longer.
well, that might be my tracing not being perfect, but they are the same. Alright, so they come out the same. So the reason I named that F and D is because that point F is actually called the focus of the parabola, and D is called the directrix. So, where could you actually see a parabola used? So let's say that you have a headlight, okay, on a car. So if you look at a headlight, the back of the headlight, it's going to be all like a silver foil, like very reflective. And you might have a bulb that comes out right there. And the bulb might have a cover over that half of it. So there's actually, you don't even see any light coming out directly from that bulb. There's a little cover. Well, what happens is if you reflect something using a parabolic reflector, or something that's reflective in the shape of a parabola, the light will bounce, hit that, and come straight out. Hit that, and come straight out. Hit that, and come straight out. Just a magical thing that happens with parabolas.
So how does high beams work?
High beam?
They only
Well, it's brighter, but I don't know if it's like angled a little different.
Yeah, it is.
A little bit of a different angle.
Like moves the,
Sometimes the way there's two filaments in a light bulb depends on your car. Some cars have a totally different light for high beam. Some use the same bulb and it's just a different filament in the bulb. Depends on the car. I don't know what my car is. But anyway, the point here is the parabolic reflector keeps all the light going straight. Because when you put your light on, if you didn't have this little cover, you'd have light shining like this. It would just shine from that light bulb straight up. And that's not really where you want the light to go. You kind of want the light to go straight in front of you. And that's what a parabolic reflector would do. Satellite dish on like a house, kind of the same thing except in reverse. All the signals come into the satellite dish and then they're focused to one spot. And then there's usually a wire there that comes down into your house. So if you look at a satellite dish, there's a curve to it. That curve is usually in the shape of a parabola. So there's two, I guess, uses that you'd see. Yeah.
yeah.
All right, so This is basically just summarizing everything I said here, except instead of saying it as a paragraph, I'm writing it as a short equation. The distance from the focus to a specific point on the parabola, and the distance from that specific point to the directrix is always the same. So this is just saying that two different distances are always the same. Point to focus, point to directrix. Now, if you draw a line through the focus and perpendicular to the axis, perpendicular to the directrix, okay, kind of like this. I can't keep it here, but that's the best I can do. So I drew a line through the focus, that's point A, perpendicular to the directrix, that's a 90 right up there. It cuts the parabola in half. Okay, that's a line of symmetry, or axis of symmetry. Depending on which way the parabola faces, the axis of symmetry could be horizontal or vertical. In this problem, the axis of symmetry is vertical. If I drew my parabola this way, and my focus was here, the axis of symmetry would be horizontal. All right, so the point where the axis of symmetry and the parabola cross, okay, that's a special point, and that's called the vertex. Depending on which way your parabola is drawn, up, down, left, or right, the vertex is either the lowest, the highest, the rightmost, or the leftmost point. But that's the vertex. It's where the line of symmetry crosses the parabola. Okay, and if you wanted to get kind of fancy, you could also say that if you were standing right here, it would be perfectly flat. The parabola is perfectly flat. It has a slope of 0, right at the bottom and at the top. It's the only part that's perfectly flat. And because it's perfectly flat, it's very easy to find using calculus. If you know calculus and you know that the parabola is flat right there, you can find that spot very easy. You can also find it without calculus. Thank you. All right, what else do we have? Okay, so that's something we're really going to spend a ton of time on. I'm just going to tell you what the term means. But they have a special term for the width of the parabola. Now, the width is always changing, because the parabolas just get wider and wider. But if you measure the width through the focus at that specific spot, they call that the lattice distance, or your book refers to it as the lattice rectum distance. I don't know why. That's just what they call it.
Sure.
But it's in your packet.
Okay.
Now, when you get a problem in the homework, if it says to you, like, you know, find the directrix, find the focus, say which way the parabola opens, and find the lattice distance, anything that the packet asks you to do with lattice stuff, you can ignore. Okay, you don't have to do anything with lattice stuff. But all that it really means is finding the length of something. It's not that hard to do, really. If you know these 2 points, you can figure out exactly how far apart they are. Just use the distance formula. But it's not something we're going to focus on. Focus. See what I did there? Focus. Wasn't funny at all. So there's 4 different equations for a parabola. One that opens up, one that opens down, one that opens left, one that opens right. Bless you. We're going to look first at the equation that has the parabola with the vertex at the origin. And let's see, if you look at your chart on page 381, it tells you all about that equation. It's the first one in table 1. This is the equation of a parabola that opens to the right. Okay. So it looks like that.
Can she just sit here and take a test?
Yeah. So some things they're going to ask you to find on parabolas. They got a chart, the vertex. Well, if you look at all of them in the table, the vertex is 0, 0 for everything we're going to do at first. Okay. The focus, right? They give you a formula to find that. The directrix, they give you, that's the second or third column. The equation is the fourth column, and then the description is the fifth column. Okay. So different kinds of things they can ask you. They could give you an equation and say, make a sketch. Or they could give you a sketch and say, what would the equation be? Or they could just give you an equation and say, just describe the equation. Tell us where the focus would be. Say which way the parabola would open. Okay, stuff like that. Okay, we'll try a little of each one. So if they ask you to graph a parabola, the most important thing to find is the vertex. Because the vertex tells you like the tip of the parabola. Whether that's the highest, the lowest, it depends on which way it opens. Okay, but the vertex gives you the tip. The focus and the directrix, those aren't really part of the parabola. Okay, if we go back and look at the picture, the focus is just an imaginary point inside the parabola. Okay? The directrix is an imaginary line that the parabola bends away from. Okay? So that's important to remember. When you graph it, the parabola bends away from the directrix and around the focus. Okay, parabola always wraps right around the focus. Now, having the vertex, that's good, but you really need probably about 3 points to sketch a parabola with the amount of accuracy I would like you to have. So, if you know the focus, if you can find another point above and below, that'll give you a pretty good sketch. Okay. Now, if the parabola opened up, it wouldn't make sense to find a point above and below the focus. Left and right. That's what you'd be looking for. Okay, so when you graph a parabola, try to get 3 points, and then just connect them. Okay. Any questions on that idea? Okay, let's look at an example. So, I want to find an equation of the parabola where the vertex is at the origin and the focus is at 3, 0. So the first thing you have to decide is when you look at that chart, you've got 4 different formulas to pick from. You've got to figure out which one of the 4 you have to use. The way you figure it out is graph those 2 points. If you graph them correctly, you should be able to figure out which way the parabola is going to open. Okay? So we're just doing a quick sketch. This isn't going to be the final sketch, just real quick. Vertex, focus. What did I say about the parabola when you draw it in relation to the focus? Yeah?
The focus should be like in the middle, like this symmetric.
Okay, so which way would the parabola have to open here to do that? To the right. Okay, the parabola should wrap around the focus. Okay, kind of like that. Now that we know the parabola opens right, we're going to look at the table, which you can use, and we're going to look up the equation that says parabola opening to the right. So, looking at the table, what does it say that the equation is? for a parabola that opens right? Yeah?
I squared equals 4ax.
Yes. Now, when you write your final answer, there's only one thing you have to find. That. You have to find A. You don't worry about y, you don't worry about x. Just like in y equals mx plus b, you have to find the m and the b. Well, here, you don't have an m and a b, you have an A. And that's all you have to find. All right. So, I'm going to give you a hint at how to find A. A is the distance between the focus and the vertex. A is the distance between the focus and the vertex. Yeah, in this case it's going to be 3. Now, you could also say this. A is the distance between, because remember, there's always 2 distances in a parabola that are the same. The distance from somewhere to the focus and from somewhere to the, does anyone remember the other thing? The directrix. We don't have the directrix here, so that wouldn't help in this one, but it might help later on. So you can think of A as the distance between the focus and the vertex, or A is the distance between the vertex and the directrix. Same thing. All right, so this one is the one that's going to help this time. Jake just said distance between focus and vertex, 3 units. A is 3. Fill in 3, and that's your equation. So y squared equals 12x. Okay, so we got the first part, find an equation. Now, graph it. Okay, so vertex is at 0, 0. I'm going to have that. You can put the focus on there if you want, but is the parabola going to go through it? No, it's going to wrap around it, so it doesn't really help. Now, the distance we just said, the distance from the vertex to the focus is the same as the vertex to the directrix. So if the focus is 3 units to the right, where would the directrix be? Negative 3. It would be right here. That would be your directrix. And the parabola is going to bend away from it and open to the right. But how wide does it open? For that, we need a couple, let's get a couple points. So, we've got to pick a number for x. What would be an easy number I could pick for x? Because look at the calculation I'm going to have to do in a minute. I'm going to have to get y by itself. 3. 3 would be a good number. You could do 1 or 2, but I need a calculator. Right? 3 is easy. Let x equal 3. You get y squared equals 12 times 3. What's 12 times 3?
36.
36. And now, how do you get rid of that square on the y? Yep, you're going to square root. And now you got to be careful. What is the square root of 36? Yes, positive and negative. That's what's going to give you the symmetry. So what are the 2 points we're graphing? Okay, x is 3, and you get 6. If x is 3, you get negative 6. So graph both those points. 3, 4, 5, 6. 3, 1, 2, 3, 4, 5, 6. And now you've got 3 points. That's good enough. To draw your parabola, kind of like that. Good. Any questions on how we got the equation or how I sketched it? We're not going to spend a lot of time on sketching. That's probably the one we'll do, but there will be one sketch on the test. I think there's 3 questions on stuff from today. So one will be kind of like this.
Are we all done?
No. Almost. Okay, this is another kind of question. This is a discuss. Discuss just means describing. You don't have to sketch it. Just tell me this stuff. Now, this isn't written the way it should be to discuss it. Y squared equals 8x. If you look at your table, what number does every equation have in it? Has a 4. That doesn't have a 4. It's kind of like saying this doesn't have a 4. Well, it did have a 4 before you did some arithmetic. So we kind of have to figure out what arithmetic did they do to get 8. 2. 4 times 2x. And now we just pointed to it in the last problem. The number that's next to 4 is what? What variable? It's a. So what's a in this case? There's your 2. And there's your a. So a is 2. All right? Our vertex has always been where?
0, 0.
It's always 0, 0. You'll know when it's not. Okay? But for these kind of problems, it's 0, 0. Now, the focus.
Is 2.
The chart tells you how to find it. This is a parabola. Y squared with a positive 4 on the other side. Which type of parabola is this? Opens right, left, down, up.
Opens right.
It opens right. The equation y squared with a positive 4 on the other side says it opens right. What's the formula for the focus if it opens right? It's a 0, which in our case becomes 2, 0. So we got that. We already answered which way it opens. It opens to the right. And what's the formula for the directrix? What else? It's we got to write a whole equation.
Y squared equals negative ax.
X equals negative a. Okay, there's two types of equations: x equals and y equals. X equals is vertical. Y equals is horizontal. Okay. So x equals negative a, which in our case becomes x equals negative 2. So when they ask you to discuss a parabola, that's all you have to say. These 4 things. And you can use this chart to figure it out. Questions on that one? Okay. All right, another discuss. X squared equals negative 12y. All right, so what we want to do first is rewrite this so it has a 4. How would this look? Negative 4, 3. There you go. There's your A. And if you're not sure, you're like, well, wait, should the negative go with the 4 or should it go with the 3? It always goes with the 4. It never goes with the number inside. Okay. So A is 3. Okay. X squared, negative 4. Look at your table. What does it say when you have x squared with a negative 4? Which way does it open? It opens down. That's the last row in the table. The formula for the focus is what?
0, negative a.
0, negative a. Well, a is 3. So what's the focus?
0,
0, negative 3. Directrix. Okay, formula for that. Y equals a. So in my case, y equals 3. Okay, we got the directrix. And what does it say the vertex is? It says this for all of them. 0, 0. Again, you're going to know when it's not 0, 0. The equation's going to have a couple extra numbers in it. 0, 0. Okay. Any questions on how we got all that? Yeah.
Maybe I missed it, but how do you know that it's -4 times 3 and not 4 times -3?
Because the negative always goes in the front with the 4. Yep. A is always positive. A is always greater than 0. So don't ever put the negative with the A. If you do, it's gonna reverse everything. Okay, so vertex. 0, 0. Good. Focus. 0, -3. Okay, it should open down because it's going to wrap around the focus. Directrix, y equals 3. It should bend away from the directrix. Now, we really need 2 other points. Look at this original equation. This time we're going to pick a number for y. We don't normally do that, but because I always pick for what's on the right-hand side. That's what I pick for. So what would be a good number to pick for y? And keep in mind what you're going to have to do. So if we do 3, what's -12 times 3? And what's the square root of -36? It's imaginary. Now, the reason we couldn't pick 3 is because, look at, does the parabola go up here? No. You've got to pick values that are down here. So -3 would be a good one. Yep. You could also pick -12. That one would work. I just don't have enough room on my grid, but it would work. Hey, so let y equal -3. X squared equals -12 times -3, which is 36. They don't all come out to 36, just one did. And what's the square root of 36? Plus or minus 6. So you get 2 coordinates out of that. Plus 6, -3. Minus 6, -3. And that's where the symmetry is going to come in for the parabola. So we got right 6, down 3. Let's see. 1, 2, 3, 4, 5, 6. I don't know if I counted right. Yeah, I guess I did. And then left 6, down 3. So this is actually the same parabola we drew first time. It has the same width. It's just opening a different way. This one opens down. Any question on it? Okay, that'll be the last sketch that we do. Okay, this one. Find an equation. All right, so this time I'm not going to sketch it. I might use this like a quick sketch to help me, but I'm not really going to sketch something like nice. So find an equation of a parabola that has that focus and that directrix. You already wrote this down in your notes earlier. I'm just writing it, remind you again. What should you always try to figure out about the parabola first? Bless you. Well, something kind of even like bigger about the parabola. Yeah, figure out which way it opens. Okay? Because if you can figure out which way it opens, then everything else will kind of happen automatic. The directrix is at -4. How would I draw y equals -4? What kind of line is that? Horizontal, because it's y equals at what number? -4. 1, 2, 3, 4. There's my directrix. Where's my focus? 0, 4. 0, 1, 2, 3, 4. Now, the vertex. What's the relationship if you compare the distance from the vertex to the focus and the vertex to the directrix? It's the same. So where would the vertex have to be so it comes out the same? It's got to be at 0, 0. 1, 2, 3, 4. 1, 2, 3, 4. Now, which way does the parabola have to open? It's got to open up. It's got to wrap around the focus and bend away from the directrix. Okay. What's your equation for a parabola opening up? X squared equals 4ay. Now, just tell me what a is based on that definition. A is 4. Distance from focus to vertex. So x squared would equal 16y. Now, that answer is fine. But if you're going to type that in on a calculator, like right here, and graph it, what would you have to do? Like, look at the equations there. They all have what letter by themselves? Y. So if you want to type that in and graph it, you got to get the y by itself. So how would you put the 16 on the other side? Divide by 16. That's the same thing. So if you have a multiple choice question and you see, you're like, wait, I got this, and you don't see x squared equals, maybe they got y by itself. I always do it this way first. Always, because that's what the chart tells me to do. If I need to move something after, then I will. Now, what number is in front of x in the top here? 1. So that's exactly the same as saying this. All those things are the same. You can put 1 over 16 like that, or you can put 1 over 16 like that. It makes no difference. So any questions on figuring out the equation on that one? If it was a short answer question, I would accept any of those. If it's matching, you might have to figure out which one matches yours. Okay, another find the equation. This time we got some different information. So we've got the vertex, right there, 0, 0. We've got the axis of symmetry as the x-axis. If your axis of symmetry is horizontal, that limits you to your parabola opening one of two ways.
Right or left?
It's got to open either left or right. That's the only way the axis of symmetry can be horizontal. But we know one other thing. The point -1/2, 2 is on the graph. So which way would the parabola have to open to go through that point? It would have to open left. If it opened right, it would never go through it. Okay, so it's got to open left. And that's the most important thing to figure out. Now, what's the equation of a parabola that opens left? Y squared equals -4ax. And what letter do I need to figure out? I've got to figure out my a. So a is the distance from the vertex to the focus. I don't know the focus, so I can't do that. But I know something else. A is the distance from the vertex to the directrix. Don't know the directrix. But there's a piece of information we haven't used yet. What haven't I used here? I haven't used this point. What is this? If you had to give a letter to that value, what is it? That's an x. And what's that? A y. So take the x, take the y, plug them in, and then you can figure out what a is. So 2 squared equals -4a, and x is -1/2. Okay, what's 2 squared? 4. And what's -4 times -1/2? So 2. So what's a? 2. So now we've got a. Just go back to your formula and write the final answer, just filling in the a. So y squared equals, what's -4 times 2? -8x. There's your formula. So a little tricky because we had to use this x and y to figure out a. But there's always enough information to find a somehow. Okay, any question on that? All right, so last thing.
Actually, yeah.
Yes?
We graphed it the other time, put it in the calculator. We had to get y along. What are we going to do?
You're not going to have to graph that, but if you did, you'd have to do it like this. You'd have to take the square root of each side. Just like that. And if you're saying, well, wait, how can you take the square root of a negative? That's okay because there's a letter next to it. So maybe that letter would cancel out the negative. But yep, that's how you do it. Because when you graph a parabola on the calculator, you would graph the top half and then the bottom half separate. So it would be two different colors. All right. So this is the final table. So if you're going to put a table on your reference sheet, you can put this one. But this one has everything the other one had and what we're going to need to do the next step. So this is the only difference. The vertex isn't always at the origin. Okay. The two letters that they use for when the vertex isn't at the origin, H, comma, K. And this table is on page, which page?
383.
Yep, 383. I'll probably write that later on. But it's page 383. Now, if you cross out all the H's and K's here, you would go exactly back to the previous chart. Like pretend this H didn't exist. You get x equals negative a. If you go look at the simple chart, that's what it's going to say. Right? Pretend k and h didn't exist. Y squared equals 4ax. That's exactly what we had in the simpler chart. So basically, you've been doing this chart all along. It's just that the vertex was always 0, 0. Well, if you fill in a 0 for k and a 0 for h, you don't even need them. Now they might not be zeros. So again, you can write this down, but there's 4 of these rows, so it's a lot of stuff. That's why it's all in your packet. So if you're going to make a reference sheet, I would just, you could cut that out and put it on your packet.
I can cut it out.
Yeah, you could cut it out.
Yay.
Fun with scissors. Okay. But it's pretty much the same basic formulas. Y squared with a positive 4. Y squared with a negative 4. X squared with a positive 4. X squared with a negative 4. Okay, so there's 3 letters you have to remember now. H, comma, K. That's your vertex. And then A is the same as it always was. So I'm writing it again. I've already written this three times now. A is the distance from the focus to the vertex. Or A is the distance from the vertex to the directrix. Same thing. Just depends on what you know. All right, let's keep that up. And it's kind of hard to see, but you got it in your book. Okay, so find the equation of this parabola. Yeah, that's pretty much it. Okay, so how many letters do we need to find now? We always have to find A, but what else do we have to figure out now? H and K. So let's go H, K, A. We have H and K. Yeah, what are they? Negative 2 and 3. So once we know what formula to plug into, we already have the 2 numbers to plug in. Now we need A. What I would do is draw it out. The vertex is left 2, up 3. Okay. The focus is up 3. Focus, vertex. Focus, vertex. So what is A? 2. The focus and the vertex are 1, 2 units apart. So now you've got everything you need, but you still have to decide which way the parabola opens. And that'll tell you which one of these 4 equations to use. Which way does this parabola open?
To the right.
It's got to open to the right. It has to wrap around the focus. If it opened left, up, or down, it wouldn't do that. Opens right. Let's scroll up. Opens right. There's the formula you want to use. So we've got y minus k. So what's that going to be? Y minus 3 squared equals 4a. So what am I going to put?
2.
Well, 4 times 2, 8. So we're going to put 8 in parentheses x minus h. Now be careful. It's going to be x minus minus 2. X plus 2. And that's the equation of the parabola. So if you notice every formula, one side is squared. Either the y is squared or the x is squared. But the other side isn't. And that's what always happens with a parabola. Parabolas involve 2 variables. We usually call them x and y. One side is squared. The other side isn't. Yeah?
Parabolas. Do they ever, or are we ever going to do parabolas that go on an angle, like
No.
directly?
Nope. The only parabolas we do are directly up, down, left, or right. You could do parabolas that are kind of like this, maybe. That gets probably a lot more complicated. Off the top of my head, I'd have to think about how to do that. Okay? So, just summarizing, parabolas always involve one variable that's squared and one variable that's basically to the first power, or linear. If both variables are squared, that's different. Now we could start to get into an ellipse, or a circle, or other stuff. Okay? Or hyperbola, yes. But parabolas are always the easy one to find because one of the variables is squared and one of them isn't. Kind of makes them stand out. Okay, so test tomorrow, second to last test. We had one last academic week that counted on term 4. This one's on term 4. Next one's on term 4. Okay, so homework 11 to 18, I think that's all matching, so that's very quick. 19 to 31. They ask you to do a few different things. Okay, you can ignore the directions that they give you. That's all I want you to do. Find the equation and graph it. Okay, so you got like 6 of those or so, and then 37 to 41. Yeah, if you need a piece of graph paper, I can print some out. Yes. Hey, don't forget I'm after school today if you need to finish up anything from last.